Okay, we are officially recording. Everyone can see
Oh,
Zero getting mad at me for not answering his Instagram DMs.
hello everyone. Welcome to this week's Yas Weekly. I don't know if there's music on the stream or not. I can't tell. Um, so hopefully I don't get copyrighted or anything. Welcome to today's Yas Weekly. Today we're gonna be talking about shooting on the move, and we're gonna be just like Orbit by the end of this.
Yes,
Okay?
better actually.
Yeah, this we're gonna be better than Orbit. Why? Because we use YAMS and they don't. And I'm gonna show you how to do shoot on the move with YAMS. And it's all gonna start with copy and pasting from the actual GitHub itself.
Zero
We love
replied to your
that.
DM. You should be happy now.
Okay, look. We're gonna go into the code for yet another software suite, YAMS. If you haven't looked at this yet, are you sleeping under a rock? Because this is great, especially if you're using YAMS. Why are you hand coding everything? You can copy and paste. Anyways, so what you're going to search up is going to be shoot on the move, I think.
Hand coding? Yeah, we
No,
vibe code. Trust.
I was
No, we
going
don't
to align.
need to be
I just
vibe.
want
Dude, there's an
to
FTC programmer that's trying to join my team right now, and my guy unironically vibe codes. He's doing his best though.
okay,
I'm proud of him.
you can vibe code in FTC. FRC is like a different story.
Actually,
Okay,
that's what I've done. Get
anyways,
bread.
you're gonna search up align to in YAMS, and what you're gonna pop up is this commands folder, and this is your holy grail of gold. This is your gold mine right here. Okay, so what do we have in this folder? We have align to goal and a shoot on the move command. Here's the difference between these two. Let's say you don't have a turret and you want to do hub tracking because that's the meta, right? Be able to shoot anywhere from any distance. This is also for your fixed shooter as well, because if you don't have a turret, you're going to use a line to goal. And what it's going to do right now, it's using a what is it? It's using the YAMS swerve subsystem, but it's pretty easy. It's not that hard to integrate it with YGSL. From my experience, I'm going to show that a little later. But this is what you get to start with. You get YAMS aligned to goal, and you have your swerve subsystem initialized as well as your target pose. This is a command, by the way. You're extending command base. I actually never done one of these before until now because I'm so used to just slapping the command method function into the subsystem. But it's really cool to see. I know a lot of other teams do this instead. So what you're gonna do is you're gonna create your interpolating double tree map. And if you're like me when I first saw this and you're like, hey, what's a tree? I'm a programmer. I don't touch grass. Yeah, same. I was that too.
Mm.
But it's actually not that hard to understand. So interpolating double tree map, basically what it does is that you have a collection of points, right? It's a lot of data, and then uh you go input in a piece of data, and it's gonna try to calculate the nearest coordinate points or data points, and then it's gonna take that value. So, for example, let's say, for example, you just had a number line it has 2, 4, and 7, and you have a data point at 9. What it's gonna do, since 9 doesn't actually exist, it's gonna go to the closest point that does exist in this double pollating tree map, and it's gonna go to 7. And so we can apply this very easily to the rest of our shoot on the move code, or shoot anywhere code. Let's even call that shoot from anywhere code. What we're gonna do is we're gonna have a bunch of data points of all the velocities we need, angles that our hub needs to be, the direction, whatever, blah blah blah. And what we're going to do is going to collect that all into a interpolating double tree map. And then from that, you have a map of the field where actually there's a really good graphic on this. Where's that thread? you know, shoot on the move thread
Oh yeah.
right here.
It is right
Yeah, there's a
underneath.
shoot on the fly thread that's really useful,
It's right under
explaining
general.
stuff. Okay, look at this, right? This is kind of, I believe, is a visualization of a double tree map. You have kind of your points, and then if you're in any of these like hexagons, right? That's like the closest data point for your code to shoot at that specific distance or specific velocity. So even if you copy and paste shoot on the move code, you're gonna have to do your fair bit of tuning because it doesn't run on black magic and in fact runs on a bunch of tested data points and kind of basically generates that closest point or entry degree, whatever. Make sense?
Any question? If you
Also,
guys
I've
have any
not been looking at my comments. Um, hi.
magic. Okay, where the tree comes
Okay,
from is like a bunch of math. More in that
magic.
thread
It is in
again.
fact magic, not. Let's see.
God,
Okay, so you got your profile controller. This is a line to goal, not turret yet. We're gonna get to turret soon. Just hold your horses. You're gonna, you know, this is your constructor where when you initialize the command, your whatever you're initializing it in, you're gonna need your swerve subsystem, your swerve input stream, your shooter system, which is just your flywheel, and then the target pose, which is gonna be the hub, and then let's see here here is how you're gonna do your double interpolating tree map whatever, right? um let's see, for every entry that is in the list of let's see, so this is the list that you have for how far away it is and how much your velocity of the flywheel has to be. That basically is your data points, right? So uh ideally you have a bajillion of these for every single point on the map where you're planning on shooting at least. So it should look a lot like these little hexagons here. You're gonna place your robot and you're gonna find that ideal velocity and distance away from that target pose, and then from there, you're gonna run through that entire loop, and then that loop is gonna put that all that data into a table, and that table is gonna go to your double polating tree map shooter table because that's what that is. And that's how you create your table, and then you're gonna add your little requirements, which is based on your swerve and your shooter, and that's gonna be put in. Hi.
hi.
Um, after that, you're going to initialize everything. When the command initialize, you're going to reset your PID controller. You know, you're going
Mom,
to
I'm on
get
an
the
important
current
call.
pose of your
Please.
swerve drive and the speed of your swerve drive, right? The direction it's going, how fast it is. That's all getting done every time you call this command. So if you're like calling this command constantly, then it's just gonna run. It's gonna get this information constantly, and then once it executes, it's gonna do a bunch of fancy math stuff. Not really. Um, let's see. Var robot speeds. So it gets the robot speed. It gets the future pose. So it's gonna predict its next pose while it's moving. If you're okay, so shooting on the move is gonna be a lot harder to do than just regular stationary shoot, but from any distance. And so this code will work stationary as well. You don't have to start with shooting on the move. Shooting on the move takes a lot more tuning, but if you are just planning on stationary movement and you just want the hub tracking, it's going to be this, right? Oh yeah, good call.
Yeah, I
um
literally just got everything set up, so I'm apologize for meeting a little time.
yeah, and then I'll send the link to the Bronc Botz code because that also uses YGSL, and I think that'll be useful. Okay, and then get target vector. So you're gonna get the goal location, and that's just the translation of that. You remember this is all being put into your constructor when you initialize it, the command, and so you can have multiple target poses, you know, um, but this is just the one that you're using right now. So let's say it's the hub for now. goal location gets the target minus the future pose. So it calculates the distance between your future foes to your the goal that you're trying to get, and it gets that distance as a targeted vector. Um, get that collects, and then now you're going to calculate the ideal shot. This is going to be when it's stationary, and you're going to get that ideal horizontal speed based on, remember, that interpolating double tree map. Is there an acronym for this? Like,
Um, just call it a map. Like interpolating double tree is like nerdy as heck. You can just call it a map.
I sound so smart when I say it though. And honestly, I didn't know what it was till I made an intern Google it for me.
Did we
I
explain it?
don't Google. I don't Google stuff. If I need to know something I don't know, I ask an intern to Google it for me because I'm too lazy to Google it.
I'm the opposite. I have to Google things for my interns because they'll come to me with questions and I'll be like, I don't know. I'll have to pull up the
Google it
documentation for
yourself.
them.
Anyways, yeah. So, gets that closest data point to that ideal horizontal speed. Therefore, what's the moral of the story? Get as many data points as possible because you don't want your closest data point to be 20 feet away from your actual robot's current location. I mean, unless you have like a spot where your robot's actually shooting, like a little you don't want to shoot in the corners, then yeah, you don't have to go the entire side. But
I'm on the wrong.
that's gonna play effect.
Cool.
We can create an acronym. I can't think of any good ones. I kind of like saying interpolating double tree map. Anyways,
Any?
translation target vector. Yeah.
No, I'm trying to think of anything else I have to add. Okay, this is for shooting on the move. Like
This is
specifically.
okay. This is for not turrets.
Yeah. This is like.
We'll get to
Yeah. Well, the shoot on the move here is also for a non-turret because it's from 63328 spot, which is not a turret, but you can adapt it for a turret pretty easily. You just pass the whatever.
No. This is definitely for turret. This one right here, I think.
I think we converted it, no? Because at the top I'm pretty sure this was for mechanical advantage.
No. This is from the shoot on the move. This blog post. This is a great blog post, by the way. Actually fully read the whole thing, but guess who did?
Oh, I'm confusing this with the initial. They made an initial version, and that version was like.
Anyways, everyone thank N-Strike in the chat for providing such lovely examples, or more like providing the YAMS example. Also, thank whoever the guy was, Ishwark. I don't know who made this, but this is like the greatest thing ever.
We should link that
great.
too.
It is linked in the example. So.
Oh, cool. We'll put it in the description too, just in case people can't read it.
Speaking of which, I need to upload the last week and this week's.
We will. At some point.
I feel like I'm 3 weeks behind actually on the videos. Anyways, you got your latency. So this is the time between when the robot is being told to move and when that shooter actually shoots. So your shooter has a little delay to it, especially when you have something like, the indexer and it's charging up its like velocity. There's a little bit of latency and this can be calibrated to your robot. So yay, something else to tune. Oh my god, I only have a week till my competition.
Yo, we'll be alright. I hope.
That thing programmed. Anyways, you got your favorite interpolating double tree map. And if you don't know, wait, what? Did I switch? Okay, I'm still actually supposed to be talking about the swerve drive, right? When did I do that? Anyways, align the goal. It subtracts your shot. Ta-da. And then converts to control. Why does it say turret angle here?
Because the original thing was for a turret. Okay. It's like the method for a turret and a swerve is the exact same. Instead of giving the heading to the turret, you just give it to the swerve drive instead. So
yeah,
I think this was originally turret, which would explain the name, but whatever. It works.
Yeah. So yeah, this is actually your not your turret angle. This is your swerve drive angle. Because
Yeah.
remember, you know this because we didn't initialize a turret. We initialized your shooter and your swerve subsystem. Shooter does not exist. A turret does not exist. So this is actually your swerve drive angle. And why is this important? Is because your swerve drive does not have any constraints. If you have a fixed shooter, you can technically change your turret code in your code. I think you can just straight up use this code. I'm pretty
Yeah.
sure
No.
if you don't have a turret.
Okay. Notice what line is it that where they literally just feed it into there. Hold on. I mean, also, nobody. We're looking at the example that Nstrike sent, right? Because apparently there's a less complete one. He pinged us with
Um,
it.
this is the okay. This is the shooter. I'm talking. I'm on a line to goal. The
Yeah.
one of the four fixtures.
Yeah.
Um,
Anyway, line 130, right? Uh, yeah.
yeah. Robot distance relative. Get field. Get gyro angle. New rotation. Original speed.
Wait, they
This
got
doesn't
the.
change
Hold on. They got
warp
the
drive.
turret angle. They get the new horizontal speed from the shot vertical. Oh, from the shot vector. They get an
Oh, right
output.
here.
The feed forward.
Output.
What line is it? Oh.
I think you actually have to set the turret this turret angle to your swerve drive angle yourself, as that was not graciously provided for you.
Wait, does this. Hold on.
Whoa. You can switch to editor? What does this do?
This
Oh my
lets.
god, you can
Wait, what?
type code and
Yo, how did you
what?
do this?
Whoa! I just typed on GitHub. And
What?
so okay,
That's so cool.
I guess swerve if you had a thing, you had your swerve drive, whatever object that was created, and then you're gonna do like aim at, right? Something. Your aim function in YGSL or whatever, set heading, whatever that was called, and then you're gonna just put that as your turret angle, which we created earlier. And then it's gonna be something like that. Hey, what's the blog post link? The blog post link is someone can you guys someone provide the link to
Yeah,
that?
I just
Actually, I can
sent
do
it
it
into.
myself.
I just sent it in the chat. I got it.
You got it. You got it.
I'm doing something. Wait, I'm like
Okay, yeah,
suspicious.
but that's how you do. That's kind of how you do that. Don't copy this because I don't actually remember what the actual method was. Um, but that's the general idea, right? You take your swerve drive object, you do your swerve input stream, whatever your actually this should be your swerve input stream. Um,
Yeah, it's doing it to swerve drive directly or to swerve subsystem directly. I'm not sure
yeah.
if it's supposed to do that, but that works technically. I think.
Well, no, this is remember this is YAMS.
Yeah.
Um, YAMS swerve. It's a little different to YGSL, but if you're using YGSL, there's an AMAT function. Turn angle. I think there's actually a new method. That's pretty recent. That's specifically made for this. Kind of
Um.
forgot what that one was.
Wait, that angle just gives you a heading, no? Because that's a degrees. Dot aim takes
Um,
up post 2D.
yeah. Dot aim. There's another one. There's a new method I think that was recently added to YGSL API. Um,
Check the
I'm
locking
assuming you
function.
use YGSL. Also, I hate when my computer does
For
that.
output, new state
Hmm.
turret angle.
Okay, so whenever figure that one out for me, I'm gonna move on. Whatever the method is.
Yeah,
But
I'll
yeah, that was
work
kind
on
of.
it.
Oh, look at this. Eh, I actually don't know how I did that. Wait,
No,
I
this is
can
real magic. Okay, math is understandable. I can't understand what you're doing.
look. I click on this
Uh
and I
huh.
just type on my keyboard, and then I do switch to editor. Maybe it's just because I don't think I have actually any special privileges. That's
Maybe.
still really cool. Didn't know that. Anyways, let's move on to shooting on the move. This is for your actual turret. Same stuff. You're gonna have, your suppliers, which is gonna be your robot pose, your speed, your goal pose. And then you're also going to have, what is it? I'm gonna pull up my own code because I think that one made sense. This one's also publicly available, guys. I believe in open source code.
I'm gonna find the way
It's
to.
very
Open source code is everything.
woo.
Orbit is like one of the greatest programming teams in the world, and they aren't open source code, which is like, yo, they
Hi.
could. It's
Okay.
so close to greatness.
Okay. This is my code, and I believe I actually don't know if this works or not. I kind of just adjusted whatever this was.
I can check and
Okay.
see if it
Well,
works.
I'm gonna pull up. This is fresh Bronc codes here. So you're gonna have your suppliers, right? That's in the original. And then I also initialized all my subsystems in here as well because I put them into my this thing constructor. That's what they're called. That way, this command actually sets the angle of that stuff in the command for me. It's just what I believe this
Ma,
is.
please.
Here's the latency on between when your shooter shoots and it actually shoots. So if there's a bit of delay, calibrate this to your own code. Then you in your constructor here, you're gonna have once again your favorite thing in the world, your interpolating double tree map data point.
Yo.
Woo! So this is gonna be your distance. I actually think that this interpolating double tree map is also wrong because it doesn't have the angle of your hood subsystem. By the way, my hood subsystem is not an arm, it's a pivot. I don't know how many other people have like done this or realized this.
We did that, and a fellow team of ours that uses YAMS programmed it with a pivot, and it did not work. Then they programmed it with an arm, and then it did work. So
See,
there's
the
that.
thing is with a pivot, right? You set it at like what 25-degree angle. That 25-degree angle does not correlate to the ball being at 25 degrees.
Yeah.
um yeah,
RPM.
and so currently mine's a pivot right now.
How many entries do you need in an articulation table for best accuracy?
That depends on um how where the heck are you shooting, right? Let's go pull back this. So this white spot here, I'm gonna assume is the hub, right?
Mm-hmm.
And
Because you can't shoot
ideally,
into there.
yeah, the more the better, right? As if I only had 2 points, if I had a point here and I had a point here, right, and I am shooting like over here or over here, it's just gonna take this pose or the closest point data point I have, which is gonna be this one. But obviously, that's not always gonna be the most accurate. Like if I'm here, it's not gonna take like the midpoint of this or this. It's either gonna take either this data point or this data point.
Mm-hmm.
And so ideally, you're gonna have kind of your field, and you're gonna have a lot of data points in the spots you actually are gonna be shooting at. Like I understand you're not calculating a point from over here unless you are shooting from over there. I think you probably should want to shoot over there because this is like a defense zone.
Yeah.
Um,
If you're like a fixed shooter, then you want to be in those corners so that defense can't kill you. But that's strategy.
yeah. Ideally, you want to cover everywhere on here, um, especially the distance, how far away you are from the hub, and you want that angle for it. Yeah.
I will say that the more points you get, the more hexagons you have, so the smaller each hexagon is because now you have more data. So now you can have a different
Mm-hmm.
angle for each point better.
Yep. Longest data is good. Okay, so I think the first thing that needs in this code that you're probably gonna have to change, minus the like initialization of your turret and hood and whatnot, is gonna be this list, this tree should have um should have 3 points if you're using a turret. Your what is it? Distance from your hub, your RPM of your flywheel shooter, and the hood angle.
Yeah.
Honestly, shouldn't this also have the turret angle?
Well, you
If I
kind of take care of that in a line to goal, so you can get away with not having it here. Although Technically, yes, but it still works without it.
No, actually, you want that to be not taken care here, because if your robot's facing different directions the entire time, then your turret angle isn't always going to be 30 degrees, relative to the robot. So yeah, that makes sense why it's not. Okay. And then you're going to add all that requirements. So here, I need to make a note to myself. Make more points for distance, um, distance, flywheel speed. I can't type. And hood angle. But yeah, I'm gonna need to test the hood angle being a pivot thing, because that's my biggest like scare right now is might
Honestly,
not work.
the only reason I think it would affect it is if your like hood was like genuinely somewhat heavy, like if it had some weight to it. Um,
Yeah,
but if it's like a relatively light hood, then you shouldn't really have issues.
I didn't really have issues. Yeah. Um.
Because all the arm does is just like calculate for the actual weight of the arm and then the length of it, etc. But
Yeah. There isn't any, so I think I'm fine with the pivot. Anyways, it's initialized. Nothing happens when it's initialized, which is different from the swerve drive for some reason.
what are we looking at? Which line?
Look, the line like 57 or whatever. No, okay, the initialization of the command. If you go to your align goal one,
Mm-hmm.
when we initialized it, we did a reset with the swerve drive. This
Oh,
I'm guessing.
well, you don't. As far as the shoot on the move command is concerned, you're just pulling from that data table. So there's not. Okay, align to goal is literally like recalculating it. So the PID controller needs to be reset with the new like current state, right? But for
Yeah.
shoot on the move, you're just pulling it from that table. So you're not actually
Mhm.
calculating anything. You just kind of take wherever you're at and you just like plug it into the table and then you get your values.
You're
So
so right. You're so
you,
smart.
I do my best. I try.
Okay. Yas did not come with this. Take that blog post, run, fly with it. This is how you use it with YAMS. Okay, you get your robot speed. Ta-da! Um, you get that, and you're gonna go find your future pose once again. Of course, if you're not shooting on the move yet, you this is okay. You can still keep this line of code. That shouldn't matter. This should be working with stationary and also moving on the shooting on the move. Then you're gonna get your target vectors. I love how clean this code is. I don't. This is great. You get your goal location. So this is gonna be the hub or your pass location. You can initialize this command multiple times again. I'm gonna was it leak some, ruin the surprise a little bit by showing you how I kind of initialized it because I believe it's kind of important.
Oh
Did
my
I
goodness
actually finish
gracious.
initializing it?
Your
This is
stream is
my.
dying. Give it a minute to like reset. Like just don't move. One sec. Okay. Yeah, it survived now.
Okay. Hi.
Hi.
Let's let's look at that.
Oh,
Ooh.
for everyone
Okay.
watching the stream or watching the video after the fact, these links will be in the description so you can like follow along there and not be confused by the stream. Trust.
Why do you gotta say that? Now I got more work to do. Okay.
It'll be fine.
Anyways, here's how I initialized the command. I got my shoot on the move command, and every single object that I had up there, right here, all my subsystems, I have it down here because I need to do it after my swerve input stream, and then I take my drive to drive base. I get the pose as its supplier, your angular velocity, the location of the hub, and then my turret, hood, and turret flywheel objects. And if I go in here, that's my swerve input stream. And then my get to pose supplier. This one was not provided by YAMS. Um, oh, a lambda. That's how you did that. I get it now. I didn't
Lambdas are
create
magical.
this. My co captain figured that one out for me.
Let's go for co-captains.
Woo! Go Woolly Bee. Go. Is she in here?
I think
I think
she was here earlier.
she's in here.
She was.
But yep. Anyways, yep, that's cool. This is how you make a supplier or you return a supplier. That's really cool. Anyways, that's how we're gonna use shooting on the move for or initializing that, and that's how we get all of our, all of this random variables or translation to these and whatnot. I think the only other thing I also
Oh, she's
changed
here. She's a speaker.
for hi, what's up?
Hello.
Hello. Yeah, and then the last thing I changed, this is field constants by mechanical advantage. Great, but you're gonna need to make your hub pose a pose 2D for your shoot to on the move to work. So this
Yes.
is what I got right now. I think this is hypothetically working. So you got your April tag, and you're getting the X and Y. You're getting the little offset of it a little bit, and then you get your rotation 2D, which is whatever it is, because I don't really care about what it is, and because they provide it as translation 3D, which is great. I don't actually need this. I need the 2D version,
If you
and so
need the
this
height,
is
if you ever need the height, just store it separately. You can just make a double for it.
hey, look at that.
Woohoo!
Advantage, guys. Great stuff.
They're nerds, but our favorite nerds.
Yeah. Anyways, shoot on the move. We're back here now, and this is where we're gonna get our vector subtraction. You're gonna get your translation 2D, your robot speed, and then your robot meters per second, and then that's your valve vector. What does valve stand for? Velocity.
Velocity.
Yep.
Jinx.
And then you get your shot vector, which is gonna take your target, your basically the distance. What is target vect actually? This, your goal location. Okay. This is your goal, and you are going to divide that distance times the ideal horizontal speed. So basically, whatever you got from your interpolating double tree map minus your robot vector velocity.
Oh, you divide by distance so that you can turn it into a unit vector. That way you only care about the direction, and then now you only care about the direction, you can easily turn it from a distance vector into a speed vector.
Is this like a physics formula I should have memorized? Because that sounded really familiar.
It's not. Well, it's not a formula, but it
It's
is a
vector
physics thing.
subtraction. Wait a minute, it's vector subtraction. I should know this.
Vector subtraction is fun.
Yeah, so I slept through that lesson during class.
Like, half of the things you've done have been, like, during your pre-cal class. Like, I feel like you spend
And
less
I
time in class than more
slept
time
through
in class.
most of it. It's crazy how I'm a straight A student, guys. Just convert
Goodness
two
gracious.
controls. Okay, you now get your turret angle, and you do that by getting your shot vector, which is from up here. You're gonna get the angle of that, and you're gonna get that in degrees. And then you're gonna do the same for your new horizontal speed. So this is the velocity that you need your flywheels to go at, I'm pretty sure. And this is gonna be, what is get norm?
I am checking. Oh, it's from the fuel
Return to
sim.
norm.
Well, no, it's not from the fuel sim. I have to check my physics definitions. It's for a normal vector, but I forgot. A normal vector is a parallel vector to another vector. So, or sorry, perpendicular. Words are hard. I don't know why she wants the perpendicular vector, though. New horizontal speed. Oh, because whatever your shot vector is, your horizontal vector is going to be perpendicular to it. That makes sense. If I
Okay.
did physics correctly, at least. I should clone your GitHub. I should steal it.
I really think you really should, so then you can also contribute to my GitHub and then help me fix things that I don't want to
Fine,
fix.
I will. I'll clone it now since I gotta check
Yay!
what the heck that method is anyway.
Guys, clone the Botz GitHub. I've been trying to get the stat up for a while. Anyways, total exit velocity. This is assuming the exit velocity variable hood. Why do I need this? Let's see.
What do we got? Total exit velocity. This is the velocity you want the ball to exit at. You might want it to not exit too fast, in which case, understandable. Also depends on
So
like.
this is like the bare. This is like bare minimum you can release at. I'm guessing.
Yes. Wait, I should
Or-
stop trying to. Ugh, my laptop's gonna hit me.
Clamp to avoid domain errors. We need if we need more speed than possible. So math.clamp, very cool. I'm guessing this do they want it on the ratio here?
What are they asking? Map.clamp.
Math.clamp. This ratio is for the speed of the flywheel, which is fine. I think this is for the hood.
That is
Cause
them
like
clamping. Map.min. They're trying to
oh
clamp the heck? Yeah, they're asking for the minimum so it doesn't go above 1. Oh,
mm,
I think I get it. Okay. So, how do I explain this in English?
explain it in not English.
It's like it's really nerdy. Okay, basically, they're looking at the horizontal velocity and then they're checking that compared to their initial velocity, right? If their new horizontal velocity is a factor higher than their total exit velocity, then it's too high for them. It's too much higher than their total exit velocity. So they're just gonna go with like 1, and then they're just gonna have that. Wait, they're doing a cosine. Why are they doing that? Arc cosine?
Arc cosine the ratio.
I think we might have to get the whiteboard out because they're low key working in 2 dimensions.
Okay, so what I'm getting at, this is a fraction. And this fraction here, if
Well,
one is the
it's cosine.
and
It's supposed to be cosine. Although, then that means total exit velocity isn't the exit velocity of the. Oh, okay, wait. They're having the flywheel travel at a constant speed, right? The flywheel is always going to give it a constant speed, and like the. Okay, triangle of doom, right? You have a right triangle of doom, and then the hypotenuse
wait, wait,
is
wait, 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 wait,
the.
wait, wait, wait. Let me pull up MS Paint. Let me pull up MS Paint.
MS Paint, my goat! The greatest thing that we ever created in the history of creation. Wait, I also gotta pull up the.
God.
Um,
Okay,
wait,
so
commands.
let's draw Billy the robot here, and we also got our awesome hub, right?
Yes.
Um, yay.
Wait, how
So
is this
that's
so
Billy
accurate? How are you doing
the I used MS Paint as a kid.
I'm impressed. Oh, impressed.
And then we got this is a right triangle. And if you ever watch that one Technoblade episode, you know, a squared plus b squared equals c squared,
I'm linking that
they had
video.
school kids. I don't know, it's like the dream PvP one.
It's the greatest. It's like YouTube history right there.
It is. Okay. A squared plus b squared equals c squared. You know, I was explaining the distance formula to this one judge, like about like limelight localization. I just started rambling about different like formulas. Like, yeah, we use the distance formula a squared plus b squared equals c squared to calculate the distance of the April tag. Like,
Okay,
what am I talking about?
I'm sorry, but if they don't know the Pythagorean theorem, they have bigger issues. Okay. Anyway, the ball it goes on that green line, that amazing like hypotenuse of doom. Chris, stop making fun of me. It's still history. That's like saying you don't look at the Mona Lisa because it's old. Okay. Like, be better. Anyway, um, your horizontal velocity is the blue line. Okay. Or well, we're technically in 3 dimensions, but for now we'll just say it's the blue line to so that we don't all end ourselves. And then the green is the direction the ball is traveling, right? So if you have uh-huh.
Go. I was
Okay.
cheering you on.
Yippee. Okay. So if you have a like shooter of doom, right? Your flywheel is spinning at a constant velocity because that's the whole reason you put a hood on your bot. So you don't have to constantly change the velocity of your flywheel every 20 seconds. Because
Oh, you make so much sense now.
I do my best. So because the flywheel velocity is constant, right? The velocity you're sending the ball at out is constant because it's getting all of its speed from that flywheel, which is traveling at the same speed all the time. So the only thing that really, oh my goodness, Chris, I'm not, Chris, we record these. You can go back and listen. Anyway, once you sent it out that direction, right? You're basically just solving for what the, oh my goodness, I just lost the thing. Hold on, one sec. I have to pull this back up. This is how I think,
Your
by the
MS
way. No, I have to pull up the code so I can like read it and then I can explain it like almost line by line, or as close as I can get to line by line. Okay, yeah, so your total exit velocity is a constant, right? But when you calculate your new vector might have a new horizontal speed that's greater than like what your bot can do, right? So basically what you're going to do is that you're going to take the cosine angle. Yeah, you're going to take the cosine of the angle you're shooting out of, right? Which is equivalent to your new horizontal.
So theta is here, guys.
Yeah.
Just in case you don't remember what trig is, maybe we have freshmen here. Theta here, cosine is gonna be the alligator of the triangle. Like it's the, what is it? Adjacent over hypotenuse.
Yes.
So this alligator here is your cosine. I'm gonna make this a different color.
They're being
Whoa.
they're being like total nerds about this. I don't know why. But anyway, right? You calculate your angle and your angle is like low key. I need you to shoot at a vector that has a horizontal velocity that is low key faster than what you can actually do, right? So what we're going to do
Wait, sorry. Okay, clarification. This horizontal, the x here is speed faster than I can do.
Yeah. This is the speed of your bot going in the X direction. Or well, this is just the speed of your bot in general. Speed of your bot.
Okay, speed of bot.
Yeah.
Speed of bot.
Like it's just whatever the speed of your bot is that we decided you need.
That I need.
Okay. Wait, I think, okay, small confusion, so I will slow down all the way back. We just calculated a brand new angle, right, to shoot the ball out at?
We're calculating theta here.
Yes, we just calculated theta. Theta...
We just calculated theta with what?
With your table from earlier.
Oh. We already know what theta is.
Yeah, we know what theta is, right? We already solved for theta. Now, theta helps us make this triangle, right? So because of that, theta is a vector with an x direction, okay? Now, all we're trying to figure out is if that x direction is like low-key impossible, okay? And if that x direction is impossible, then we need to recalculate our theta to get an x direction that is possible. Does that make sense?
Yeah. If it is impossible, redo calcs.
Okay. And please, anyone who has questions, just you can just say I'm confused in the chat, and I'll like go all the way back. But anyway, because we are recalculating. Huh?
My math teacher is like, oh, you have a question? You don't know the difference between a sine and cosine graph? Screw you! You're such a loser. You weren't paying attention.
You should low-key jump them. That's like the worst thing ever.
Okay. Anyways, yeah.
Anyway.
So, we know what theta is, and because our double tree map. But if this speed that we need to get there is faster than what we actually have, what we're gonna do is we're gonna just redo those calculations because that's impossible. We're gonna use a different theta.
Exactly, and basically we just reuse like the maximum theta our bot can do. That's why we set the cosine theta to 1. That's just when cosine theta equals 1. Theta is just like 0 degrees. So we're saying basically just shoot straight forward if your x direction is too high. Because when we're basically what we're okay,
guys,
I lied to you earlier. I lied to you earlier.
You did.
The blue line is not the speed of the robot. The blue line is the speed of the ball. And then exit velocity is the speed of
Yeah, I thought I was tweaking, but you're smarter than me, so I listen to you.
Don't do that. I'm sometimes like stupid. But anyway, so when the x direction of your ball is impossible, we need to recalculate theta, basically. Okay? So all they're doing is that they're just looking at cosine of theta, and then we're saying, okay, hypothetically, if the hypotenuse of the ball was the maximum possible speed that we can shoot out at, our total exit velocity, right? Would this horizontal section be possible? Would this horizontal section for our speed be possible if we were shooting at like the maximum possible velocity? If it is possible, then we're just going to go with the theta we calculated. But if it's not possible, then we're just going to go with a theta of 0 to maximize that extraction as much as we can. And we might miss, probably. But, like, better to try than to not try. Okay?
Okay,
So,
so we have theta, and we know what like this speed
mhm.
needs to be, and
Yes.
then we know what this speed needs to be. We can calculate the cosine of that to
Mhm.
get the horizontal speed of that. And if the horizontal speed is impossible, redo the calculations, which means this speed that we need is impossible with that data that we have with the current constraints of our robot.
They did it in, like, a
Oh,
really...
hi, person that just joined. We are calculating. So this is
Okay.
shoot on the move, basically, but no, we're kind of calculating more like stationary shots right now, not just shooting on the move. Because to be able to shoot on the move, you need to have it be able to shoot from anywhere, and this is how we're calculating that. This is for people who just joined. We are yoinking from YAMS shoot on the move code, which is yoinking from the eShark shoot on the move. This is so beautiful. Holy.
I don't know what... Is that Maple Sim?
There's no way that's Maple Sim.
If that is Maple Sim, I might cry.
This is kinematic testing, Linux. I don't know what that is.
I think
Unity.
I think that's a Linux version of Maple Sim. I have a sneaking
There's
suspicion.
no way.
Wait, isn't
Okay.
Instruct in here? Wouldn't he know?
No.
He's not. He left
Um.
us. Anyway, um,
Anyways, shoot
all
on
of
the
that,
move.
all of that nerding out was just to say that low key, if theta is impossible, we just set it like if theta is too low, we just set it to like the, um, we just set it to 0 basically.
Basically, we're explaining all the math for these two lines,
Yeah.
minus like all those lines, but basically just these two lines, and those two lines, while may seem simple, um, we got Pythagorean theorem.
It's just
Okay,
it's
basically,
it's the nerdiest way
basically,
possible to do that. Right?
according to your interpolating double tree map, which is basically just a collection of data points you have, and the close if you input a data that into this chart, it's gonna calculate. It's gonna find the closest coordinate point to that point and calculate. Um, it's just gonna grab that data. So if you're like if you have a point at 1 and 9 and your input a point of 8, it's going to grab whatever data point 9 is because that's the closest to that. And we can do that with speed. So like distance, the location of your robot is whatever that recorded speed was, the closest point to that. And then since we know what that speed and like angle and that we need from that data point is, because you already tuned every single possible location your robot could be on a map, you're going to have a awesome triangle
Of doom.
where you know what the angle is of doom. You're gonna
Mhm.
you know what the angle is, and you know what the directed like what speed this ball has to be to get to this target height point or whatever the hub is to score.
Mhm.
So you know what the speed is, and then you take the cosine of that to get the speed of the ball on the horizontal axis.
Yeah.
But if that is impossible due to the constraint of your robot, like for example, it's like you need your x to be at 100 million miles per hour, and you realize that's impossible, it's going to redo those calculations till it gets a hood angle, a theta, where it is possible. And your flywheel is constant, you typically, um, during this because you have a hood, and that's the whole point of a hood, is to keep the flywheel constant.
Beautiful explanation. Completely right.
Yay!
At least as far
You're such a
as
great.
I think. Yeah, I do understand. Okay, if anyone was like confused or if you're like too embarrassed to say you're confused, you can just like DM me and be like, "Yo, what the hell just happened?" And we can go through it like one more time really quickly. But if there are no more questions, I'll give y'all like a couple seconds.
Yeah. This is the code. Oh, by the way, you can just straight up edit from GitHub.
Okay,
This is
you
cool.
can because you're cool, but like I can't do that. I'm not cool enough. Goddamn.
Editor. I don't know why that. Maybe because I contributed. Like, um,
Okay, no one has any questions. So we low-key did an amazing job of explaining this. I'm sure we were completely right and made no mistakes. Um, what's
need
next?
propose change.
Yo, mute yourself,
Whoa!
bro. Bro,
I
I'm
made
this
a
is gonna
poll request.
everything that's getting said right now is gonna get posted on YouTube.
Awesome. Anyways, that's how you do that. And then once you got that done, um, basically copy paste the shoot on the move code into your robot code. You're going to initialize your variables or your subsystems, right? Put them into the constructor like this right here. That way, we
Neil,
can
shut
actually give
up.
data or the actual subsystem to these made up variables. So you put your shooter of your shooter. This is just your flywheel. You have your turret, and then you got your hood, and then that's gonna do all your robot current pose and stuff for you. Um, Here, you gotta have your interpolating double tree map,
Yeah.
which is
Yeah. Currently,
and you,
there's 3 points in there. So like, when you're copy pasting this, that is the one thing you will probably want to change. But other than that, like,
mhm, yeah.
that's it's great.
So if you have your flywheel speed, you also want your hood angle. So let's just say there's so many parentheses in this. This is the purple parentheses. This is the blue parentheses. This one. So you would do degrees of ooh, degrees of, and then you put your magnitude, and then you can do
I'll be right back in like a
whatever
minute.
34 degrees, and it's mad because I don't have degrees imported. Or actually, no, it's fine. Okay, or are you mad? Something's mad. Oh, and then in here, get entry of in RPM, and then I need entry dot get third. Let's see, is equal to degrees. How does this work? Am I missing a pair of parentheses? One. Oh, because it needs like all of them to have degrees. Well, let's do that. Let's yoink this.
I'm back. My bads.
Okay, because I'm like, did I Wi-Fi die or something?
No, I
Okay.
just had to go and like do things. Yeah.
Do you think pair of is not the thing? Is there something like
Sorry.
thirds?
What's going on? A list of pair of thirds of? Oh, are you trying to put? Wait. What are you
A
trying to
third
put?
data point.
What's the third
A
data point?
third. The degree angle. It's not pair
Of.
of.
Uh. Hold on. Wait. What file are we in?
We're
Shoot.
in the shoot move.
Okay. And we're looking at the shooter
Instead
table.
of saying that we tested angles and what's the distance interval hub, best fit line of best fit from that. So
I mean, you at that point you just do like a list. Like if you have like three of them, you just do a list. I mean,
it's just that, right?
yeah, pairs are just Java's really slow. Okay, Hippie, see, you're a normal person. Hippie just okay. So down here, right? Hippie
What?
just said that like, okay, what if you just like tested your mind out and you like tested a bunch of different angles at a bunch of different distances and you made a line of best fit from that? Yes, that like works like I don't remember the exact number. I don't even think there is an exact number. I'm just gonna say like 80%. That works 80% of the time. But let's say hypothetically you are a team that does not have a time to test, right? Not a lot of time to test, and you need a solution that works accurately. This is what you would do, right? And either way, whatever you do with those data points, you're going to have to make a table from those data points anyway, and then using that, you would plug them into here. Personally, I like the rigorous math approach more just because it accounts for more things. A line of best fit will always be somewhat off. This will also be somewhat off, but at least less so.
Do you do list stuff and list stuff again?
Do I what? Yeah, that's what I think. Because, like, okay, pair.of is just like a really, like,
It is. It is it? I don't know actually. Um, let's figure this one out. Oh, it did it. Now how do we fix this? Quick fix. Liar. So get first, get second, get third.
wait, how do I move
I
it?
wish I should have. We're working on the line of best fit right now with comp in 3 days. Oh yeah, we can totally talk about that after we get this working for my code.
Okay, no, hold on. I'm just gonna be completely clear, y'all. We are not gonna be talking about the math behind the freaking like the math you have to do for this. We are working on a Java solution right now that should just be able to get you those numbers given your constants. Um,
Oh,
but
also, because it's using a map, so the map is like a value and a key. So I don't think it allows you to put like the third argument.
Honestly, oh, you're so
oh,
right.
oh, 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 I'm stupid. I'm stupid. Nobody do pair.of, and then for your second one, do list.of. Like in the second parameter with your RPM and your degrees, make that a list.
You're so smart.
I'm so dumb.
My co-captain is so smart.
I also have a question, like why do we need to put the degrees? Because isn't that later on we already like calculate the degrees? Like the
we
angles?
so yeah, we do, but it's not entirely rigorous. Like if you do a tree map that has the hood angle coded in there, then you want to make your table work with that. So that's what nobody's doing right now.
Well, I mean, it does calculate the hood angle for you. That's the whole point of calculating theta, no?
Yeah,
So why are we doing this?
I don't know. I left and I came back and you were doing it. So I was just like, let's go.
Wait, no, we don't need to do this because, man, I hate my co-captain being right all the time. This is what she always does, by the way. Um,
I mean,
okay. Wait, no, no,
y-
no, no. This is I got like you know how like prophets are like mysterious and they give you like prophetic like information and advice that you won't understand till like 5 years later.
what, like an Egyptian oracle?
Yes, yes, yes. So
Okay,
N-Strike did this to me, being like, "You need a clamp on the hood.
that is a
We
clamp.
need a clamp on
Math.min.
the hood.
Oh,
We
yeah,
need this
like
needs to be clamped."
It is clamped.
uh,
You did that in ratio. That was the whole math you're
Oh,
explaining earlier.
that's the speed. It doesn't
No,
clamp
that's
the.
okay. We're
It,
checking. We're checking if our angle is physically possible by seeing if that angle gives us a speed that's physically possible. If that
okay, but
speed is
the
physically
hood
impossible, I'm
cannot
fixing the angle.
rotate. The hood cannot rotate 136 degrees.
Wait, is angle? Whoa.
maybe the hood
You
can
gotta
rotate.
clamp your angle.
Wait, what
Oh, we
the?
have to do a clamp on top of the clamp they did. So they did a clamp checking for
Yeah.
speed, and then we need to do a clamp checking if our hood can even actually do that angle.
Okay, so do we create a new variable for that, or do we just take this
No.
and
Just say new
because
pitch equals math.clamp new pitch, comma. Well, like
oh
your
wait, you
lower
want to
bound.
take a new variable or like take this variable?
Just do new because they're feeding a new pitch into a set angle. You can make a new variable and then replace the
Double new pitch new hood new.
new.
Or like you don't need, like you can just like put it inside the set angle arguments, whatever.
Yeah, but like readability.
Or like clarity, yeah, I know.
There's gonna be some person who's like, I have no idea what's happening. There are too many letters in this one line. I give up.
That's what I mean.
No,
Or
that's
you,
me.
Keeping it as
if you're testing the
um
code, then you're
here, fine,
yeah.
clamps
Oh my god.
No, I'm the kind of person
pitch.
who'd be trying to program everything in one line because it looks cool. And then my
You're
intern's
so
looking.
You're a menace to society for that.
My interns look at me and they're like, "What is wrong with you?" And I just
What's
apologize.
wrong? Damn. Is clamp not something that's actually like a thing, or
Did
do I
you
actually
import
use
it? Oh, it's math
clamp?
util. Oh wait, is it?
Bleh.
It should be math util. To Google. I'll Google it.
I don't believe in Googling myself.
It's okay. I will be your intern for the day.
Thank you.
Okay, it is math.clamp. Woohoo.
Capital C or lowercase c? I'm definitely sure it's lowercase.
Lowercase.
Quick fix. Configure static import. That doesn't exist. Use VS Code.
Also, never ask the Google AI to program anything ever.
That's how I cheat on my comp sci test. What do you mean?
Okay, use like, I don't know, like actually I don't know. You use like ChatGPT or something.
Wait, I'm such a genius.
You're only just realizing this? Goodness gracious. Is it math util and not math? Yes, it is math util. I'm just not very good at words. Where's the import statement?
Okay, so here, no, it's like actually called math util.
Well, yeah, but you have to import it still. Like you have to import math
Okay,
util.
it's called math.clamp.
Yeah.
It's important because I was being stupid and did math clamp,
Wait,
not math.
are we using FRC's clamp? Is this an
Is this
FRC
what this
method?
is?
Because
Is this ever seen?
that would be really funny if FRC made
Yes, it
their
is.
own. They made their own version of the dot clamp method. That is like the dumbest thing ever.
This is.
I mean, to be fair, they also like reprogrammed addition. They were like, low key, we got to make our own version of addition. I'm just like, okay, you do that.
Oh, this is the deadband code. What is this?
I like all this. What are they?
What are they on?
It's not even that deep, bro. It's
It's
not
not
even
that-
that deep.
They did it in one line.
I don't know.
Why is it an if statement actually? Oh, if the value is greater than 0, then return the deadband value. Otherwise,
Well, it's
it's
basically
the
if
same
you're.
thing.
Um,
It's the same thing.
do they not know to
What is
program?
if statement doing?
Wait, go what? If math.abs value is less than deadband? Oh, okay, wait. I know what this is. This is running like right before, like whenever you send controller inputs, it applies the deadband to it. So this is checking that like if your input is within the deadband, then just ignore it, and then
No,
everything
but
after that is just
what is the point of this?
um brain damage. That's what this is.
What is the point of this?
Extreme mental illness. That's what we're looking at.
If anyone wants to contribute to WPI Live, here's a really easy one to clean up.
They're probably doing something like there's some obscure edge case they're taking care of.
Okay, we're definitely getting sidetracked from the math util class, but yeah, this is a WPI Live thing,
Wait,
and you got your value.
Did we talk about dot? We did, right?
Anyways, I'm pretty sure this is just new pitch, and then you take the low. The low is going to be
Zero.
your
value.
min value, hood.min, hood constants.
Whoa, you
Dot,
have a constants file?
Yes,
Wow.
soft limit, min, and this should be hood constants max. I make my interns do this because I don't really know what to make them do. So, this is an angle. I need to change this into dot in degrees. Or, how do I change angle to double again?
I think it's
I
something
think
stupid
you're
like.
right.
Sorry.
Yeah,
What?
just like I think you were right. Just like in degrees or something.
Are you trying to change the
Also-
degrees into a double or a double into a degrees?
It's in
Decreasing double. Yeah.
You're
Wait,
so
also,
smart.
can you like make another one for the turret? Cause I think we also need one.
Yeah, you also have the
The
clamp
clamp.
turret. Guys, just make a turret with like an infinite degree of rotation, and then you don't have an issue.
You see, our mechanical team isn't capable of that.
It's okay. I'll build it. Me myself personally.
You, the programmer,
Hey, don't like knock on these hands. I did mech for a year, and then I promptly ran a programmer.
yay! Pivot. So you put your pivot clamp here. This is crucial, guys. If you don't do this, something might be twisting its head off.
Oh, funny story. So, we were running a PID controller on an elevator one year, and the
Yeah.
PID controller kept returning. I'm not sure if I told the story already, but the PID controller kept returning values that were too high, and it kept breaking the chain. And Mech kept on like having to fix it. And I remember telling my programming, like I didn't get what the issue was because I was an intern. No one was telling me anything. The moment someone explained it to me, I was like, "What if we just use math.clam?" And I swear to God, like my programming senior looked like he genuinely discovered fire. It was the greatest thing I think I've ever done in my entire life. I felt so great after that. Anyway, now I'm in
See,
programming.
I don't even know my Chinese remainder theorem can do 2,160 degrees. I've actually haven't tested my Chinese remainder theorem and see if it's actually correct for the turret, but like hopefully it works. Otherwise, it might make this an end strike problem.
Okay, but why would you do 2,160 degrees? Why are your degrees not multiple like between 0 and 360 and then just looping after 360?
We're not even going 360. I have a 0 to 200 and was it 10 degree limit on my turret.
Downtime? Pixel, what do you mean by downtime? Oh wait, I should probably show the chat to the
No
stream.
downtime. I guess, yeah.
Oh,
Um,
no downtime means like y'all don't go outside. I'm sorry, I can't relate because I touch grass.
no,
Unspinning,
no
just
worries.
unspin, guys. Okay.
Okay,
Wait,
clan. Yeah.
line 121. It's not the new pitch.
Dude, stop saying things that are correct, you know?
Yo.
She sounded so sad.
I'm sorry.
Clamped turret angle. Let's
No,
go.
this is great. Best programmer I could ask for. It used to be just the two of us.
Oh my god, and
Now we have.
dude, that scared me. I just saw Instruct's profile like blink, like in the corner, and I was just like, what the heck?
Yeah. Okay, so you got this. Okay, so if it is at this minimum angle, does it recalculate or does it just like totally whiffs the ball?
Sorry, what? Say that again.
Okay, because from this, right, it totally just whiffs the ball if it's like beyond the turret's capability.
Oh yeah, I mean, like if it's beyond the turret's capability, you're not gonna make the shot anyway. So this is you just going like Kobe, and you're just like doing your best shot possible. But yeah, you
Yeah,
will probably miss.
I think. Okay, I mean, would it be that hard to put like the swerve input stream and like make? But it's like so much work. The drive team can just turn the robot.
Oh, that's a smart idea actually.
Make the drive team do it, or program the swerve drive to look at it.
Both. Um, moving the swerve drive and making drive team do that.
You see, the thing is, like moving the swerve drive uncontrollably is the fact that
Bro,
what they want
we're
to
back
do
to
is
999 members. What the heck? I'm sorry. This was totally off topic.
probably because like I at channel like a lot. Actually, you've been doing that. You
Hey,
know, you have like the what is it, the trench, right? And it looks something like that. My drive team wants to like peekaboo right here, and if the swerve drive just like suddenly pivots 180 degree or like 90 degrees to the side to go shoot at the hub, might be concerning. Um, that it's
who's gonna
uncalled
tell drive
for.
team?
Hey, wait, that might be what the line to goal is for. You see, end strikes like don't use that. You don't need it. You have to shoot on the move. But like, why can't I have both? You know?
Wait, don't they do two totally different things? Doesn't align to goal align your bot to the goal and then shoot on the move, shoots on the move with the turret?
Yes, but like, okay, actually, I don't want to tune that. You know,
Actually, wait, no, he's
I feel like
right. You have a turret. You don't need both.
you don't need both. But like, but the clamp. I mean, drive team can fix that.
They can clamp the turret angle.
Drive team can move robot.
I should just make drive team program the bot at this point.
Honestly, same. They're like, the tech has to be a programmer, so if there's something wrong, they could go fix it. And I'm like, Drive Team should be able to just program the robot. Like,
I am both drive coach and probably and captain this year because I'm the one who knows how to do all the things. Not mech
oh,
though.
that's so. Anyways, that's Bronc code right there, guys.
Yeah.
Let's shoot on the move command. And yeah, any questions? Wow, we talked for more than an hour.
This was such fun. I don't know why everything I say
Was.
sounds like insincere. It really was fun. I mean that.
Yeah, I am having fun. I'm learning so much, and I got programming done, which I wouldn't have otherwise. This is great.
Does genuinely no one have any questions? Did we just okay? We're either really good at
I
this or we're really bad at this.
I think they're all just smarter than us, guys.
They're like, I
Or
already learned.
they're like someone who's playing Counter Strike 2 at the current moment.
Is he actually?
Is that not what he said?
When did he say that?
Or did I you said he was like playing something while something.
I
We're
was
starting.
so stupid. I thought he said he was watching a CS2 video. Like, computer science 2. I can't.
So it was Counter Strike 2.
It was
Yeah.
Counter Strike 2. I just don't. I'm not. Not a genius, unfortunately. That's Kanye's job. I'm a
Anyways, this
genius.
is finished. This return when the command no longer needs to execute. In my head, this command should always be running. So
What, this is finished? Make this return true when this command no longer needs to execute. I mean, like, you're never
just let the
finished.
command be interrupted.
Yeah.
Because what other command you're running alongside of this is going to be your intake command, and that's going to be run with the dot along with.
Wait, would you not just automatically hold on? Let me make sure I'm not being stupid. Okay, yeah, no, that's totally fine being solves.
Yeah. Anyways, check out Botz code, guys. I'm dying. Oh my god. Okay.
It
Yep.
looks fine. I don't know what you're complaining about. You're doing great.
Am I what?
Yeah, I mean, you have your shoot on the move stuff, right? You have your subsystems. What are you waiting for? Like, what are you panicking about?
I'm not panicking.
Oh.
I'm dying.
Oh. Aren't we all? Just slowly.
This
Okay.
is my station. Okay, yeah, but that's all. Thank you for all coming here today. Subscribe to the YouTube channel. Make sure you come back next week. Actually, next week I have comp, so
Am I
someone
hosting
else
by
is hosting.
myself next week?
I mean, okay, it's like on the Sunday is free, so I might be really tired, but I could.
Oh, Cryptic was here the whole time. He's like our expert shoot on the move person. Shout out Cryptic. Or go.
Or cryptic.
No, I just
Did I
came in.
extend it for them to talk?
Did
I don't
we,
remember if I did.
Did we extend the what?
You know what, Cryptic? You want to do a workshop next week?
What would that even be over? I'm
Um,
down. Let's go!
No, Cryptic, you're in charge. Okay, well, that's all. Bye, guys.
I'm gonna wait for people.
Bye.
Bye. Thank you for coming.
Bye. Thanks.
This was great.
You know,
Yeah.
I need like someone to like come up with an outro for me because I don't know how to end my videos. Like for the YGSO ones, it's easy. It's like happy swerving. But it's like, what do I do with yams? Happy yams?
Happy yams.
Yams?
Well, what if you just make it all fade to green? That's what I would do.
No. All the videos, if you just look at the end that are not YGSL, I'm just like panicking on like how to end the video.
I feel like this is a perfect way to end the video. Like, you just ask how you can end the video.
Yeah, if you have any suggestions on how to end videos, I'm here. Yep, happy sweet potatoes. That's no.
What will she even say?
Hit
Hit that like and subscribe button.
Bye, guys.
Let's go. Why did Game Tools open? Oh, I'm going. Bye. Oh, okay, Chris. Chris, that's on the video now.